For today's word problems, we're going to focus on perimeter and age word problems. And I want to start off with perimeter, just making sure that we're comfortable with some of these ideas of perimeter. When we're talking about perimeter, it is the distance around a shape. Most of us know that, but I think sometimes we get confused with perimeter and area. So perimeter is going to be the distance around a figure. When we're talking about a rectangle, I'm going to go ahead and just draw one for our purposes of talking about it. When we talk about a rectangle, we usually refer to length and width. So I know that in a rectangle, to get all the way around the rectangle to talk about its perimeter, I would need to not only add one length and one width, I need 4 sides, and that's going to be our key that we want to remember here. And I know you guys may be thinking, well, of course we want 4 sides. That right there is the most common mistake made with perimeter problems, just forgetting that there are 4 sides to a rectangle. So when I'm finding my perimeter, I want to take the length plus the width plus another length plus another width, or 2 lengths plus 2 widths. I usually focus on this idea of length plus width, or length plus width plus length plus width, just to make sure that we know that we've got all 4 sides accounted for. Now, in a triangle, there's only 3 sides. They are not necessarily all going to be the same length, though. So when you're talking about a triangle, we usually just refer to them as sides A, B, and C. So you would just say that to get your perimeter, you would take A plus B plus C. Keep in mind, guys, perimeter has 4 sides. That's going to be the important one. Okay, so let's take a look at a word problem with perimeter. Notice that they've talked about the length of a rectangle is 2 centimeters less than 7 times the width. And the perimeter is 60. Find the width and the length. Well, right there they tell us what we want to find. Find the width and the length. All right. Now, if we try to think of which one of these pieces do I not know anything about right now, they do tell us something about the length. They say the length of the rectangle is 2 centimeters less than 7 times the width. I know nothing about the width right now. They don't give us any pieces of information about that, so that's what's going to get the variable. Now let's read again. The length of the rectangle is, this is where our cue is that we're getting ready to start to get some important information. 2 less than, and if we think about that, less than means to subtract and to flip the order. So 2 less than 7 times the width. Well, we just called our width x, so 7 times the width would look like a 7x. I want to subtract and flip that with the 2 that we had. So the length here would be a 7x minus 2. Now let's refresh that one more time, make sure that we're good. It says, first of all, the length of the rectangle is 2 less than 7 times the width. We didn't know anything about the width. That gets our variable. 2 less than, we're subtracting and flipping that with 7 times the width. So 7x minus our 2. Now, from there, they tell us the perimeter is 60. We've been doing a lot of problems lately where we've just been doing a sum. But when we talk about perimeter, what we need to make sure we realize is that perimeter is not a sum. Perimeter is adding all 4 sides to our rectangle. So to get this perimeter of 60, we want to take our x, our 7x minus 2, there's 2 sides so far, plus another width and another length. From there, you're going to notice that we have some like terms that we can combine. We've got all of our 4 sides accounted for. So we've got a total of, let's see, here's 8 x's and another 8 x's, so we have 16 x's. And we had a minus 2 and another minus 2, so minus 4 is equal to our 60. And if we go ahead and move our 4 to the other side, if I add a 4, we're going to have a 64 is equal to our 16x. And when I divide both sides by 16, I'm left with x is 4. Now, just like every other word problem that we've been working on so far, x isn't necessarily my answer. X is, in this case, the width. The width was just referring to the x, so the width is 4. My labels here would be centimeters. But when I talk about the length I'm taking 7 times 4, which would be 28, minus 2 would be 26 centimeters. Now, to check yourself on this problem, you know that the perimeter would have to be 60. Keep in mind that's not just the sum of these two anymore. That would be adding all four sides. So 4 plus 26 plus 4 plus 26 does get you to 60. Okay, next question is a triangle. The perimeter of a triangle is 76. Now when you see that they give you the total perimeter of something is 76, that's going to be our equation that we're going to need. Then they tell us something about side A of the triangle is twice as long as side B. Side C is 1 centimeter longer than side A. Find the length of each side. Okay, so they've referred to these as side A, B, and C. Now, we need to figure out which of these pieces we know nothing about, because right now we do have some information. They do tell me something about side A, that it's twice as long as side B. They tell me something about side C, that it's 1 longer than side A. The piece that I'm missing here is side B. I have A and C, I don't know B. So I'm going to go ahead and give that my variable. And if you wanted to, you could even just call it B. Now, they tell us that side A of the triangle is twice as long as side B. Twice was that citation word that meant times 2. So we want to take 2 times side B. Well, side B we called our x, so 2 times our x would be 2x. Side C is 1 centimeter longer than, that's an addition word, but it's got the than in it, so we also want to flip. So we're adding and flipping side A. So 1 longer than side A was referred to as 2x, that's what we've established side A to be. So if I'm adding and flipping the 2x and the 1, I now have a 2x plus 1. Be careful with that one, that it's got to be 2 longer than side A, which is not just our x here. So be really cautious when you are looking for what that's going to look like in terms of variables. Now, back in the first sentence, they gave us something about the perimeter. They said the perimeter was 76. So that's going to be when I add all these sides together, that will equal 76. And of course we have some like terms to combine. We've got 5x plus 1 is equal to our 76. And if I subtract 1 from both sides, I'm going to be left with a 5x is equal to our 75. And when I divide 75 by 5, I get that x is 15. Now again, I'm not done. That's why we leave our extra column of our table. X is 15. That means that side B was 15 and our label here was centimeters. Notice that side A was 2 times that. So 2 times our 15 would give us our 30 centimeters. And side C was really just 1 more than side A. If I take 2 times my 15, I'm back at 30 plus 1 would be 31 centimeters. To check this one, we could just add all these together, and because a triangle is just the 3 sides, these 3 together should equal our 76, which they do. Okay, this next problem, if you notice there's some words in all caps, and that's kind of important. We'll get there in just a second. It says the length of a rectangle is 3 times the width. If the original length is decreased by 4 meters and the width is increased by 1 meter, the perimeter will be 66. Find the dimensions of the original rectangle. So that right there is a key word, the original rectangle. Now we're still comparing the length and the width. That's not anything different than what we've seen before. But notice here that we've got some original information, and then they kind of change our dimensions a little bit. They say that the original length is going to be decreased and the width is going to be increased. So I'm just going to write up here original and new. And our last column is going to be for our answers. Now, if you take a look at this one, let's start with just our original information. They do tell us something about the length. The length of the rectangle is 3 times the width. So right now we don't know anything about the width. That of course is going to be what gets our variable. The length is 3 times the width. If I called my width x, 3 times that width would be our 3x. Now that's our original information. That part's good. But then they change it up a little bit on us. And they say if the original length, so I'm looking at this 3x right now, is decreased by, so I'm subtracting, 4 meters. Well, now look at what I've got. My original length was my 3x is decreased by 4 meters. That is the new dimension that we're looking at here. So for my length, I'm looking at 3x minus 4. And the width, which we referred to as our x, is increased by, so we're adding 1 meter. So this is going to be an x plus 1. Now they tell me that the perimeter will be 66. Notice that that perimeter being 66 is part of the sentence that's talking about these new dimensions. That means that the perimeter is going with this new information. This is what I'm writing my equation with. So let's go ahead and let's write our equation. We're going to come back to the last sentence in just a second. Keep in mind that a rectangle has 4 sides. So when I talk about this perimeter, I'm going to have our 3x minus 4 plus our x plus 1. But it's not just a sum, it's a perimeter, plus another 3x minus 4 plus an x plus 1. There's all 4 sides. That perimeter is 66. Now, when I combine some like terms on this problem, we had 3 x's, there's another one that's 4, and another 3, and another one that's a total of 8 x's. And then I had a negative 4 plus 1, there's negative 3 so far, and then another negative 4 plus 1, so total of negative 6 is equal to 66. And when I go ahead and add our 6 to both sides, I'm left with 8x is equal to a 72. And when I divide both sides then by our 8, we're left with x is 9. Again, I'm not done. But now let's go back and let's really read that last sentence again. The last sentence said that we're supposed to find, that's what our answer column is supposed to be, the dimensions of the original rectangle. So I want to go back to these dimensions. That's what I want my answer to be. So I know what x is. X was referring to the original width. So our original width was 9 meters. And our original length was 3 times 9, so 27 meters. Again, notice that that answer column does not come from our new information. That's not what they asked for. Really look to see what they ask you to find. Find the dimensions of the original rectangle. So I'm going back to that original information to be able to come up with those answers. For this next problem, we have an age problem. And this is talking about, notice that there's just one box before we even start looking at what we're talking about. There's just one box. And that's because there's only one thing that we're looking at. We're looking at Jack. And it says that 20 more than 4 times Jack's age is the same as 6 times his age. How old is he? So I'm really just looking at Jack's age. If you just want to put Jack in your box, that's fine. Or if you want to say Jack's age, that would be great. It's the only unknown we have, so I'm going to give that the variable. Now let's really read our sentence and look for our pieces that we've got. It says 20 more than, now more than was an add and flip. 4 times Jack's age. We've called his age x, so 4 times Jack's age would be a 4x. Is the same as, we've seen that is or is the same as. If something is the same as something else, then they are equal. That's our equals word here. 6 times his age, we called his age x, so we're going to call that a 6x. So then the question is, how old is he? Notice that we really do have an equation here. I've got my 20 that I'm adding and flipping with a 4x, and it's going to equal our 6x. So let's write that equation. Don't forget to flip. So 4x plus 20 is equal to 6x. From here, it's just a basic equation to solve. Notice that I don't even have multiple pieces that I'm trying to find. I'm looking for just an x. As I subtract my 4x from both sides, I'm going to be left with 20 is equal to our 2x. And when I divide both sides by 2, I'm left with x is 10. So that means that Jack is 10 years old. This last question It's talking about Gary and Frank. So I'm going to go ahead and fill that into my table. And they tell us that Gary is 5 times as old as Frank. And 1/3 of the sum of their ages is equal to 32. Find their ages. All right, so let's start off with, who do we know nothing about? Well, they do tell us something about Gary. Gary is 5 times as old as Frank. So right now, I don't know anything about Frank. So Frank will be my variable. Now, Gary is 5 times as old as Frank. So 5 times, and I called Frank X, would be our 5X. That's going to be Gary's age. Now the next sentence is it's our equation, it's putting the stuff together with an equals. Notice it says that 1/3, don't freak out, yes we have a fraction, 1/3 of, that's our keyword to multiply, so times the sum of their ages. Let's take a look at that one. We want to add their ages, and we're doing 1/3 times that sum. In order to show that we're doing the sum of, we're adding, and we've got that keyword next to the word of, that's our reminder to put it in parentheses. So we want to add their ages, but we want to take 1/3 of the whole sum. Not just 1/3 of one of their ages or 1/3 of the other one, 1/3 of the whole sum. That is going to equal our 32. Now, if it was me, I would probably combine like terms first, because trying to take 1/3 of 5 is not going to be very pretty. Neither will be 1/3 of the x. But when I combine these, I end up with 1/3 times our 6x is equal to 32. At this point, you can clear the fraction if you want to, multiply both sides by the 3. Or this one is one that if you take 1/3 of 6, you're going to end up with just a 2x. If you think about multiplying those fractions, 1/3 times a 6 over 1, as we multiply the numerators together, you end up with a 6 divided by 3. That gives you your 2. So either way, you could clear fractions, or you could go ahead and just take the 1/3 of 6. And you get 2x is equal to 32. But we're not done yet, because we know that we also need to divide that, both sides, by 2. And that leaves us with x is 16. Which means that since x is 16, Frank is 16 years old. And Gary is going to be 80. If you take 16 times 5, that's going to give us an 80. 80 years old. The key with age problems is they're not all going to be sums, like what we've been used to doing. But here, unlike perimeter, where we have to remember 4 sides, age, just really look at the question and what it's asking you. You may have some questions where it just asks you about one person, like on the last one where we were just talking about Jack. You may have one box tables, and that's okay as well. But if you notice that you've got multiple people, the same idea is what we've been doing before.